Hello everyone, today let's solve the problem number 338 counting bits. So what the question states here, we are given an integer n and we need to return an array answer of length n plus 1. So we are given an integer n, you can clearly see here integer n, and we have to return an array answer of length n plus 1 where iterated value of the answer is represents the number of ones in the binary representation of I. So that's what they have given here. So let's try to understand the same thing with the help of example that they have given. See here, they have clearly mentioned here n equals 2. First, what we need to do, we have to consider from 0, integer 0, 1 and 2. So this one we need to consider this one into binary 0, 1 as well as 2 here. So binary representation of 0 is 0. You can just Google it just to check if you want to check. So the binary representation of 2 here 1 0, right? So here we have to count within this array, we have to count number of ones present in 0, 1 as well as 2. So in this case no ones are present, so we will be we have to return 1. In this case we have 1 1, so we will return 1, and in this case we have 1 1. You can clearly see here this one, right? We have 1 1, so we will return 1 here. So overall or the output that we need to return here is 0 1 and 1. So that's what they have given in the output as well. I hope this is completely clear. So let's come to the example 2 now. Just give me a second here. So you can clearly see here n equals 5. So we have to consider 0 1 2 3 and 4, right? So the binary representation of 0 is 0, they have given clearly, and 1 is 1 in this case. This is 2 1 0, and 3 is 1 0 0, and 4 is 1 0 1. So here we don't have this one at all, so let's consider this one entirely. Let me do one thing. Yeah, this one initially for 0 we don't have 1 at all, so it will be 0. For 1 we have 1 1, so we'll be considering 1. For 2 we have 1 1, 1 we'll consider. So for 3 we have, so here I have to consider 5 as well, right? Sorry, I forgot here. This one has to be 0 1 1 0 1 0 0 1 0 1. Did I consider 4 5 0 1 1 0 for 2? For 3 it is 1 1. For 4 it is 1 0 0 here. This one 1 0 1, sorry. Yeah, this one 1 we have. For 3 also we have 1 here. For 4 we have this one 1 as well. For 5 we have 2 ones here. For 3 also we have 2 ones here. But confused here, I have given 1 1 here. This one, sorry. For 3 we have 1. So here in this case we will be going with 2, and for the final one also we will be going with 2 here. 0 1 1 2 1 2. That is what we need to return here in this case. I hope the question is completely clear. Let's quickly discuss the approach and followed by the edge cases one by one, and then finally write the code and discuss the complexities for the code that we have written. Initially, let's discuss the approach first, right? So first thing that we need to keep in mind here is we'll be going with the dynamic programming with this one, bit manipulation or most significant bit, MSB, right? So dynamic programming, DP plus most significant bit, or the bit manipulation you can consider. I'll just consider here MSB, DP plus MSB, nothing but dynamic programming with most significant bit, right? So I have considered the first example that they have given in the question so that it will be easier to understand, right? So here we have already discussed this one. For 2, binary representation is we have to consider for 0 1 and 2. See here we have already we already have the binary representation 1, and we already have the binary representation for 0 1 and 2, 0 1 and 1 0, right? So for this one it will be 0. Number of ones here is 0, so it will be 0. Number of ones here is 1, so 1. Number of ones here is again 1, this will be 1, 0 1 1. So I hope this is clear. Now let's try let's go with the thought process. How can we articulate this one in the form of code, right? Same thing, let's try to articulate this one in the form of code. So let's try to think in that way, right? Let's go with step by step. Just give me a second here. What happened here? Yeah, this is fine. So we will be going with the formula. So this is the formula that we will be going with mainly. So here iterated value of the answer equals answer of I right shift this one, right shift I by 1, this one I'm speaking of, right shift I by 1 plus I ampersand 1. This is nothing but it checks if the last bit is 1 or not. This checks whether the last bit is 1 or not. This one is right shift I by 1. This one right shift I by 1, and this one checks if the last bit is 1 or not. This is the formula we'll be going with. Just keep this in mind. This is very important. This is the main thing actually. So sorry. Yeah, this is the main thing actually. Right. So first thing here, let's apply the formula step by step here. Right. So here, this is nothing but I. This is nothing but the binary for this one. Binary format. The number in the binary format for 0, for 1, and for 2. This is I right shift by 1. Answer of I right shift 1. I ampersand 1. We have already discussed this one. Nothing but checks. It checks if the last bit is 1 or not. And finally, this one is answer is I. Iterated value of the answer equals answer of I right shift 1 plus I ampersand 1 here. This one leads to the answer. First, we have considered 0, 1, and 2. So let me come here. This one. We have got n equals to 2. So we have to consider 0, 1, and 2 here in this way. So 0, 1, 2. For binary representation of 0 is 0, 1 is 1, and 2 is 1, 0. Here I right shift 1. This one, what we are doing here again, right? We are right shifting I by 1. Right shift I by 1. In this case 0 we got. In this case 0. Right shift I by 1. So here in this case this will be 1. Right. So in this case we don't have anything. We will write 0. In this case, sorry, we have 0, right? Right shift. This will be 1 itself. 0, 0, 1. I hope this is clear, right? I hope this is completely clear. The next step here is answer I right shift 1 we have considered right here. So this one will be 0 itself. So same thing. This one will be 0, 0, 1. So here this is the same thing as the previous step. I right shift 1 these both. So this is fun. Next one is I ampersand 1 whatever we have considered here. This one checks if the last bit is 1 or not. So here the last bit is 1. No. The last bit is 1. This one is 1. Here the last bit is 1. This one is 0. In this case, like we are doing here and, right? We are going with and, right? So that is the reason we have got 0 here, 1 and 0. Don't get confused here, right? So the final step here is this one plus this one, this one plus this one plus this one plus this one. So here this will be 0 plus 0 is 0. 0 plus 1 is nothing but 1 here. 1 plus 0 is nothing but 1 here. You can clearly see we got 0, 1 and 1. So solution that we got here is 0, 1 and 1. This is same as the output, or this is equivalent to the output that they have given for the first question. See here 0, 1, 1, and we got 0, 1, 1 as well in the approach. So the final result here is 0, 1 and 1. You can clearly see here. So the solution here is 0, 1 and 1. I hope the solution is completely clear, right? This was easy, right? So I hope the approach is completely clear, what we have discussed earlier. So we took the first example and we saw that one step by step. So now let's quickly discuss all the edge cases and then finally write the code, right? So the first edge case here is for the minimum input. So when I say minimum input, n I have considered 0 here. So the output in this case will be quite obviously 0. You can just try it out in the same way that I showed for this one, first example and the approach, right? If you want to try it out. Here the single bit in numbers n equals 1, output will be 0, 1 in this case. You can just try it out. Output will be 0, 1. First you have to convert to binary and then you have to count the ones, right? So that one you can just try it out in the same way that I showed for the example 1 in the approach. So let's move on with the third edge case here. All bits set. Here when I say all bits set, we are going with n equals 3, 7, 15, etc. in this case. So let's consider n equals 3. Just for the example sake, just consider n equals 3 here. In this case, output will be 0, 1, 1, 2. You can just try this out. You will get the output 0, 1, 1, 2 here in this case, right? So here the fourth edge case here would be large values. N equals 10 to the power of 5 we have got here. So we should check the performance here, ensuring our solution runs this one efficiently. This is for the very large value, right? We are going with the 10 to the power of 5 here in this case. So we should make sure that this one, solution runs efficiently for the n equals 10 to the power of 5 input, right? So we should check performance, ensuring our solution runs efficiently. These are the 4 edge cases that we need to consider, right? So here, let's quickly see whatever we need to consider. What are all the things that we need to consider? Minimum input. The second edge case was for single bit numbers. The third edge case was for all bit set, and the fourth edge case was for the large values. I hope all the edge cases are clear here. So now let's quickly write. Here, let's start writing the code here. The first step we will do here is, what we have to do here, we have to initialize the result array with 0 for the index 0, right? So let me give here result equals 0 within the array. So this is fine. The next step here is, let's move on with the iteration here, right? We'll start with 1, right? Index 1, I less than or equal to n. Let's increment the I here. This is fine. So the next step here is, we saw the formula during the approach. So that's what we'll be giving here. So we already know the formula here, nothing but iterated value of the answer here equals, this is DP formula, right? So we are going with a dynamic programming plus most significant bit. So this one we saw here, iterated value of the answer equals I right shift 1 plus I ampersand 1 or I and 1. This is fine. We know this one. We don't have to discuss much about it. So we have already seen this one in the approach, right? So the final step here is, we have to return the computed result or calculated result. Here this will be, I'll just give here a return result in this case, right? Let me format the code once and let me hit the run button. This is it for the code. So I hope this works. Let's see. So here answer is not defined. So here what I have done, oh yeah, this one has to be result we have considered, right? So there in the approach I had given answer, so in a hurry I have considered answer itself here. So this one, let's consider result. We have considered here variable name result, right? So this is fine. Here I have given correctly, but here I don't know why I took answer. This is fine. So let me hit the run button again. This time it has to work. Let's see. Yeah, you can clearly see here the sample test cases are getting passed here. So let me quickly hit the submit button. So here you can clearly see all the test cases are getting passed here. Means the code works absolutely correct on this case, right? So let's quickly discuss the complexities for the code that we have written. The approach that we went with here is dynamic programming, or the most significant bit, right? Dynamic programming with most significant bit, or the bit manipulation. So here in this case, the overall time complexity would be big O of n. Why it is big O of n here? Because we are iterating once over n values. We are iterating once over n values. You can clearly see here the for loop, line number 3, right? So what would be the space complexity here? The overall space complexity would be big O of n as well. So why the space complexity here is big O of n? Because we have to store the result for n plus 1 elements. We have discussed this one during the approach, right? So it stores the results for n plus 1 results, right? So here you can clearly see the line number 2 and line number 6. So overall time complexity and the space complexity here would be big of n in this case, right? So I hope the solution or the code that we have written is completely clear as well. For now, this is it. Thanks for watching, guys.